Hey guys, I'm just going to make this video hopefully to take some of the anxiety out of doing the mean and sigma or standard deviation calculations for our statistics class. You can see here that I've taken question 1, I've copied it, and I've transferred the data over here. And I'm just going to show you how you can use Excel to get through some of these frankly really complex calculations. So for A, we're asked to compute the mean number of accidents in a day. And that's pretty easy. To get the mean, what we're going to do is we're going to multiply the number of accidents in a day with the probability that there's that many accidents in a day. So we can see here there's essentially a 28% chance there's 0 accidents in a day. And all we're going to do is we're going to press equals. We're going to multiply the number of accidents times the probability that there's an accident to get the weighted probability. And we're going to drag that all the way down. And in this bottom cell here, you can see that I've summed the column. So I've summed all the weighted probabilities, and that gives us mu, or our mean. And you can see here it's 172. And you can see here that that's the correct answer. So it's a little more complex to calculate sigma or the standard deviation in these cases. I'm going to show you the formula, which is right here. It's a beast. So essentially what this formula is doing is we're going to take the number of accidents in a day minus the mean squared times the probability, and we're going to sum the whole thing, and then we're going to get the square root of that number. So really quickly, we can just use Excel to evaluate this for us. So I want you to think of these steps as really just going through BEDMAS. So the first thing we've got to handle our brackets. So we're going to press equals here. We're going to subtract the number of accidents minus the mean. And then we're going to make sure, remember, so when we drag this down to evaluate this all in really quickly, we want to make sure that we're always subtracting the mean, because we can see the mean here inside each of the brackets. So we're going to make that an absolute value. And we just drag that down. And we're going to get all of our, the inside of all of our brackets evaluated. So if you think of it this way, this would essentially be step 2 of our equation. So you can see that we've transferred these numbers down here. The inside of each of our brackets is evaluated. And the next thing we would do is we would handle our exponents. So this number to the power of 2 is this number times itself. So this is our step 2, and we can see it's just going to be step 1 squared. So we're just going to press equals. We're going to take the number in this column. We're going to multiply it by itself, so we're going to click on it twice. And that will evaluate the inside of each bracket for us. Well, that will evaluate each exponent for us. And if you sort of want to see what step we'd be on BEDMAS in the actual equation, this is sort of where we are. So we've got each number that was inside the bracket plus the exponent evaluated, and now what we're going to do is we're going to multiply each number by the probability that that number of accidents will happen. So we're going to multiply. So what we're going to do is we're going to take this number here, and we're going to multiply it by the probability, which is over here. And we can just drag this down. Now you're going to see that this is actually going to get rid of that. I don't know why it's covering that up. So if you want to see where we would be at in the equation, we would be right here. So if you can imagine, this is each multiplication equation evaluated, which would be our next step. So we could see all we need to do is sum these numbers. And if we sum those numbers, we would get 2.7186. And then we would find the square root. So this is going to be the square root function, which you can see here. So we got the square root of that number. Our final total would be 1.667813. And we can see that there is the right answer.